We've completed the layout of the user control. Now it's time to add some code. To do that, we need to go to the code behind class for this control. Easiest way to get there, right-click, View Code. Now, rather than having me type the code, I've already created a text file that contains the code, so I'll go find that. It's with the samples for this course. There it is. Now, I could have copied and pasted all this XAML. You got to watch me make it up from scratch, but for the code, I'm going to go down here to where the code starts and copy and paste the code. Now, first of all, we're going to be using a new timer that was created in the .NET Framework for WPF. And to do that, I'll need to add a using statement for system.windows.threading. Let's go over here, I'll close this. Let's go over to our class and add that using statement. I'll also need to add a couple of variables. Let's see what those variables are once I get them over here. I'm going to need a Boolean variable to keep track of whether we're currently playing or not, and a dispatcher timer variable, which will be our timer. And the point of this timer is to keep the position slider in sync with the position of the currently playing movie in the media element control. So that declares that variable there. Now we need a tick event handler for that timer, so I'll add that now. And the tick event handler just says if we're currently playing, then set the value of the position slider equal to the position of the media element control named movie player. That'll keep the two in sync. I need a constructor for my movie player control to set up a few things. So in the constructor, I'll call the base initialize component method to initialize all the bits and pieces of this user control. I'll set playing to false just to make sure it really is false, and then hook up the event handler for my timer's tick event. Now we need some private procedures to handle playing the movie and stopping the movie. So let's get these, paste them in, and see what they do. I better select them. There they are. Paste them in here. So what does play movie do? The play movie procedure says if we're not currently playing, call the play method of the media element control. Set the content of the play button control to be pause. That changes the text, so it says now pause rather than play. And set the playing variable to true, so we know we're currently playing. If we were currently playing, we pause the movie player. We set the content of the play button to be the word play. That tells us by clicking that we'll play again. And we set the playing variable to false because we're not currently playing the media. The stop movie procedure says stop the movie player. That means stops everything. Sets the position of the movie player back to 0, moves it back to the beginning of the media. Sets the content of the play button to the word play, because now we're not playing, so we want to make sure it says play so the next time you click it, it will play. And finally, we set the playing variable to false because we're not currently playing. Next, we'll add two public procedures so that code outside this control can manage the behavior of this control. There's a play movie method. We already have a play movie method. This one has a different signature. It's a different overload for that. This one takes in a string indicating the path to the movie we want to play. The source property of the media element control requires a URI. So we'll create a new URI passing in the file path to the constructor of that URI, and then call the private play movie method, which will play the movie for us. The public close method calls the stop movie procedure and then closes the movie player, which releases any handles and deinitializes the media element control. Next, we'll need event handlers for each of the buttons and sliders. Let's start with the back button. The back button has code which sets the position of the movie player to be its current position, subtracting 5,000 milliseconds, or 5 seconds. Then we set the value of the position slider to be the same as the position of the media element control, so it stays in sync as we move things around in the timing of the control. Same thing goes for the forward button. In its click event handler, what we want to do is jump ahead 5 seconds and set the position slider's value to match the position of the media element control. Not really much going on there. It's just brute force. Now we'll also need handlers for the play button and the stop button, and these are so simple I put them together. The play button calls play movie, the stop button calls stop movie. We also need event handlers for the sliders. Here is the volume slider event handler, and what it does is set the volume of the movie player to equal the value of the volume slider, so that if you change the value of volume slider, it will, of course, change the volume of the movie. We have the same sort of thing for the position slider. If you change the value of the position slider, you want it to change the position of the media element control to match, and that's what this code does. Now there are two events of the movie player, that is the media element control itself. We have media opened and media ended that we'll need to react to. It has other events as well. These are the two we have to care about. In the media opened event, we need to do a few things. We need to set the volume of the movie player to equal the value of the volume slider. By default, the volume slider is halfway through its possible values. We set the movie player's volume at the same place. We need to set the maximum for the position slider to be the length of the movie. To do that, we use the natural duration property of the movie player, that is the media element control, get its time span, and retrieve the total milliseconds in that time span. We set the maximum of the position slider to match. In addition, we need to set the timer so that it ticks every 1 second. We set the interval of the timer and then start the timer. In the media ended event, we stop the movie and also stop the timer, so it stops attempting to update the position of the slider on the form. Well, that's all the code we need. Now we need to hook up the various event handlers. To do that, we'll go back to our movie player control in its layout and add the hookups that we need. Now I need more room for the XAML window here, so I'm going to swap these, minimize the layout window, so I have room to work with the XAML. Let's start by going to the media element control, which is here, and we need to add a hookup for the media opened event. Media opened, there it is, and we'll set that to movie player underscore media opened. Okay, we also need to add a hookup for the media ended event. Let's go get that one. Media ended, there it is, and we'll hook that one up as well. Okay, next, let's go to our buttons. For the buttons, we need to add click event handlers. So here, I'll add click equals, we need to type it correctly, and we need the back button underscore click event handler. Here, I need to add a click event handler, and for the play button, I use play button underscore click. For the stop button, for the click event handler, I'll add stop button underscore click, and for the forward button, I'll add the forward button underscore click. There we go. Now here we have the volume slider. For this one, let's add, for its value changed event, let's add a hookup to the volume slider underscore value changed, and for the position slider, which is up here somewhere, here it is, for the position slider, we'll add value changed and hook up the position slider underscore value changed. So we've hooked up all of the events, we've added all the code, so our control is ready to go. I'll save it, and now we're ready to add an instance of this control to our main form. In order to use the new control on our form, we need some way to reference it, and we need to be able to refer to classes within the current assembly to do that. In order to refer to a class in the assembly, you need to add an XML namespace reference to your main form, and it's going to look like this: XML NS : whatever abbreviation you like equals CLR-namespace : your application namespace. Without that reference in the main form, you won't be able to refer to any class within your own assembly, because you have namespaces that refer to classes in the .NET Framework assembly, but nothing that hooks up the classes in your own assembly. The CLR-namespace name indicates that what follows is a CLR namespace, which you've created in your assembly. In this case, it's the namespace containing the class you want to reference. So we'll have something like this: XML NS : I use local, you can use whatever you like, equals, and now the string CLR-namespace : the name of your default namespace, which by default is the name of your project, which is Video Browser in this case. The specific namespace, which I use local, is arbitrary. Choose whatever you like. But you need something there, and then you'll use local : from then on to refer to anything in the current assembly. Let's try it. Before we start hooking things up, I want to remind you what the reason for these namespaces here is. Now, if you'll remember, we have elements here that define the layout of this WPF application. But these are just XML elements. The XAML is just XML. So when it comes time to render this thing, somebody's got to take those XML elements and convert them into instances of .NET Framework classes. So when we see a slider or a grid or anything else in here that uses the default namespace, because there's no prefix, we're using the default namespace, the compiler says, oh, he wants a stack panel element. I need to go map that to the corresponding class that lives in a .NET Framework namespace for WPF, and it does that by using this namespace reference, which internally maps to a group of .NET Framework classes and namespaces. The same for X : class up here. How does it know what to do with that? Well, it knows that it needs to create an instance of something that it finds in the .NET Framework namespaces that are mapped with this namespace reference. We don't need to care specifically what those are, but that's why those namespace references need to be there. If we're going to refer to a class in our own assembly, we need to add our own namespace reference. Well, before we do that, let's make sure this all builds. So I'll rebuild the solution. The error here tells me that Media Player Control already defines a member called Movie Player Control with the same parameter types. If I go there, oh, I see. What happened is I pasted in the new constructor, but didn't overlay or delete the old one, which is here. Can't have two constructors, obviously. Let me delete that one, rebuild this. Let's try to fix this one. It's looking for timer_tick. Did I miss the timer_tick handler? Yes, I did. Look, I spelled it wrong. Boy, I was having a hard day here. Let's fix that up and try building again. And now life is good. All right, so we've got a clean working example. Well, not working yet till we hook it up, but we have a clean build of this thing. Okay, let's go back to our window1.xaml and add the namespace reference that we need. I'll clear some space out, go to my code file, and copy and paste that in. So that says from now on, anything we have with the local prefix is referring to the assembly named Video Browser. Well, let's go add a reference to our own user control. I'll copy and paste it and we'll see what it looks like. Here, within this grid element, let's add that. We get a little squiggle here. It's complaining. We'll compile. It'll work fine. So it's saying we want to add a reference to a local : movie player control. We have a movie player control, and we want it to go in grid.row equals 2. Now for user controls, you really have to use X : name, not just name, because this is something that's outside the standard WPF world. So the X : indicates its reference through this namespace. This is just one of those tricks you learn after a while. For user controls, you use X : name to define the name of the control. That's because we'll need to programmatically interact with this control and hook up events and so on. Let's rebuild this thing. Seems to build just fine. Did the squiggle go away? Nope. Squiggle didn't go away, but it should work fine. Let's look at the layout and see. Here's our layout. There's our control, so clearly it's happy. So we've laid out our main form and placed onto it our new user control. Well, we can try it. I'm not sure what it's going to do, but we can certainly see if it does something. Let's run it. There it is. There is our media element control. There's our movie player user control. Of course, clicking the button doesn't really do anything yet, so we can't really play something. Actually, you know what we could do is we could hard code the behavior. To hard code the behavior, let's just double-click the button to add the click event handler. Let me add some code that will get the value for us. So when I click that button, we're just going to play a movie. Of course, I have the wrong path here. Let's go find the real path. There's our movie folder. Let's get that. And let's play reports.wmv. Okay, so here we are. And we'll play reports.wmv just to see if this thing works. Okay, I'll save it and run it. And there's our form all ready to go. I'll click the button and play the movie. Now, of course, I've muted the audio. There's no point hearing Robert and me at the same time. But we can do things like stop, and that resets it back to the beginning. I click play, and now it starts from the beginning again. I can jump forward 5 seconds at a time. I can jump backwards 5 seconds at a time, and so on. So this thing appears to actually work. And watch as the movie plays, the position slider does keep itself updated to match the position of the video, and so on. And when I close this thing, everything cleans up after itself. There we go. So we have a working project. One of the goals of this demonstration was to create and bind the list box on the form to display a list of thumbnails. It would be easiest to create a collection of thumbnails and bind the list box items directly to that collection. That's what we'll do. We'll create a class named Thumbnail List, and that class will provide the collection we need. To create the Thumbnail List class, we could look at some of the historical ways that the .NET Framework has allowed you to create a custom collection class. But there is a new technique in the .NET Framework 3.5, which is the Observable Collection class. This class, besides creating a generic collection class, it provides application notification of changes to the collection, so that if someone adds, removes, changes, or moves an item in the collection, it raises events that your application can handle. It also notifies the application through an event when the entire list is refreshed. Now, I must confess, we don't need any of that for this demonstration, but it's important to know about the Observable Collection class because it's a really nice way that's new to handle a collection of items so that you get notified if someone outside your code modifies that collection. The consumer can add event handlers for events such as collection changed or property changed. Whoever is consuming the collection class can handle those events. The sample won't use those event handlers, but it could. In this case, there's no way any code outside of the video browser application could change what's in that collection. The Observable Collection class creates an internal collection and will use members of that class to manipulate the collection. Besides the internal collection of file names, the Thumbnail List class will expose only a single property, the folder name property, and you'll set that folder name property to indicate where the class should look for JPG files to display in the list box. The problem is you can't specify this in the Thumbnail List constructor. You have to explicitly set it later, and there's a reason for that. The reason is the main form is going to use declarative data binding we set up at design time. The binding is performed as the application loads, before the list has been filled with values. If you create the instance of the Thumbnail List class at the same time you supply the path name, the list box will never show any data. The problem is the code must allow you to specify the folder name after the Thumbnail List class is created. You could work around this by using dynamic binding, that is, hooking up the binding for the list box at runtime. But that's not the point of this demonstration. The point of this demonstration is to show how to hook up design time declarative data binding. So in this case, we'll need to have a single line of code that sets the folder name property of the thumbnail list instance after the form has been created. So that's why you'll see the one extra line of code where you thought you might be able to hook it up in the constructor of the thumbnail list class. This is a long-winded explanation of why we see one specific line of code. Well, let's add the code to create the thumbnail list class and to hook it up. I'll need to add to our project the new thumbnail list class. So I'll right-click, choose Add Class, and name it Thumbnail List. There's the new class. We'll need some import statements to save us some typing later on. Let's go get those now. There they are. We need system.io because we'll be working with files and folders, and we need system.collections.objectModel because that's the namespace that contains our observable collection class. Now we need this class to inherit from observable collection, so I'll just go get the code that makes it happen. Here we go. I could have typed this, of course. It wasn't very much code. There we are. And now our thumbnail list class inherits from observable collection of string, so the only thing we can place in the internal collection is a string. We're going to need our folder name property, so let's go get that now. And in the simplest sense, all this does is get and set a private field. If that's all it did, I could have used an automatic property in C#. But the fact is the setter actually does a bit more work. The set also needs to, as you can see here, go out to the folder in question. Let's replace this. Go out to the folder in question and retrieve all the files. It does that by starting out. Oh, wait, I overwrote the get. That's not going to work. Let's overwrite the set instead. There we go. Here, in the setter, we start out by, of course, storing the value into our private field, then clearing the internal collection. Because every time we set the value of the folder name, we want to clear the internal collection. Now we'll loop through all the files we find by calling directory.getFiles, passing in the folder name, and using star.jpg as our file specification. For each file we find, we add the file name to the internal collection. The reason this class has an add method is because it inherits from observable collection. Well, that's all the code we need. We have our folder name property exposed publicly so that anyone can set the property to fill the list of all the available JPG files. The example uses declarative data binding to bind listbox items to the thumbnail list class. By declarative data binding, I mean we set up the data binding at design time by adding XML markup to the XAML window. We have to add code to window 1, setting up the instance of the thumbnail list class. Someone's got to create that instance, and our code will do that. We'll also use the folder browser dialog class, which actually comes to us from the Windows Forms namespace of classes, to display the folder browser dialog. To do that, we have to add a reference to system.windows.forms because it isn't part of WPF. Finally, in order for binding to work, Window 1's thumbnails property must be public. It's exposed publicly so we can see it from our XAML markup. Well, let's now prepare the Window 1 class to hook up the data binding. In order to use that folder browser dialog, I'll have to add a reference explicitly to the system.windows.forms. That reference isn't set by default. Although there's no shame in doing this, because the .NET Framework includes this assembly no matter what, it'll be there on the client machine, it will look, well, like a Windows form dialog. Let's go find that. I typed it wrong. System.windows.forms. There we are. Great. And now in window1.xaml, here we are, we need to go look at the code. So I'll right-click, choose View Code, and here's the code for our video browser. We'll need to add a using statement for that namespace. I'm going to actually give it a prefix so I can refer to it using that prefix. WFS is going to equal system.windows.forms, so that when we see WFS dot in our code, it will remind us that that class is coming from the Windows Forms set of classes. Okay, well, let's add our thumbnail list property. I'll get that from our code file here. There it is. Let's examine what that's doing. This is, well, it's got a private field, underscore thumbnails, which has a new instance of the thumbnail list class, which we've just created. And here we have a public property to get and set that value. Remember, in order for data binding to work, this property must be set as public. Well, let's go back to our Select Folder button and make this actually work using the Folder Browser dialog. I don't need that code anymore. Let's add the real code and let's see what it's doing. This shouldn't be a surprise if you've worked with the Folder Browser dialog in the past. This creates a new instance of the wfs.folderbrowser dialog, sets the root folder to be my computer, calls the show dialog method, and if the result is okay, sets the folder name property of the thumbnails class to be the selected path in the folder browser. Now remember what setting the folder name property will do. Setting the folder name property of the thumbnails instance, which is right here, will also fill the internal collection of that class instance with all the JPG files in the selected folder. Well, we've added all the code we need. It's time to hook up the data binding. To display the list of JPG files, we could, I guess, go out and find the list ourselves and manually add them to the list box. But what fun would that be? We'll instead use data binding, which makes it automatic. All we have to do is set a single XAML attribute, and the data binding will happen magically. Let's give it a try. Remember, what we're trying to do here is modify the binding of the list box. So I need to go to the markup for window1.xaml, find that list box element. Here it is. We need to add something which indicates how we want to perform the binding. I'll put that right here. Let's go get that from our code file. I could copy in the entire element, but I won't. I'll just get that one attribute I need to add. There it is. And this sets the items source attribute for this list box. Let's get it all in view. There we go. The item source attribute indicates for the list box where it should get its items. The curly braces on the right-hand side indicate we need to evaluate this expression when we perform the rendering of this page. The binding text here refers to a class in the .NET framework which handles binding on WPF applications. The element name attribute here indicates where we want to look for the data we're binding. In this case, it's the video window class. That's referred to, remember, up here. Where's the name? I'm looking. It's set up somewhere. Well, that's going to be a problem because we never set the name property of this thing. If we haven't set the name for this, it can't possibly work. We'll have to take care of that in a minute. Video window, and then the path tells us which property of that class to use. In this case, the thumbnails property. So that one line of code hooks up our data binding for the list box. Of course, we'll need to set the video window name. We haven't done that yet. We'll do that in a minute. If you want more information about the binding class, look up documentation on the system.windows.data.binding class. You'll see information about the element name, the path properties, and so on for that class in the .NET framework. Well, let's take care of our binding problem here. We never set the name of the main window to be video window. This can't possibly work. So we need to add a name element here for the main window, so the code knows where to find the thumbnails property. Without that, we could never find it. That's why you need to make sure you add a name attribute for anything you ever want to refer to programmatically later on. Before we go any farther, let's review the data binding syntax. It looks something like this in our markup. Now here, the item source attribute specifies the source for items in the list box. The curly braces indicate markup extension syntax, such that what's inside this needs to be evaluated to determine what the item source actually is. It allows markup to extend the standard XAML syntax, and it creates an instance of a specific class supplying property values. In this case, the class is that binding class. The syntax always starts with a class name, and it may or may not omit extension at the end of the name. For example, it could say binding extension or just binding. Either way, you can see it there or not. Within the syntax, note property names and values. Element name and path are properties of the binding class. The element name property indicates where to look for the data you're going to bind, and the path property says which property of that instance you're going to use to retrieve the data. This markup extension is really a shortcut for internal elements. You could use elements instead, and the example is a shortcut for this. We could have had listbox.itemSource, and inside there, a standard element, binding, path equals thumbnails, element name equals video window. It just makes it a little shorter, that's all. Either way, we get the same behavior. Just remember that whenever you see that curly brace extension markup, you can get the same behavior using elements if you want to. I'm going to mention here that WPF data binding is a huge topic. We're just covering one simple example. There's a lot of features in WPF data binding that standard Windows forms don't support. You can bind anything to anything else in WPF, and they'll take care of all the details for you. You may have to write a little code, as you'll see in this demonstration, but you can bind anything you want. In this example, we're simply binding an observable collection to the item source of a list box. I've done the data binding and hooked that up. Now I need to add the code so that when we click on the list box, in the selection changed event, we hook everything up. So let me remove this error first, then double-click the list box, taking us to the selection changed event handler. Let's get the code for this event handler and then see what it does. This code starts by closing the movie player control. By closing it, that makes sure that if you were playing a movie previously, you reset everything inside that media element control so it's ready to load a new movie. We'll get the image name variable from the selected item in the video list box converted to a string. Because the item comes out as an object, we have to cast it as a string to store it in a string. We'll find the associated movie. To do that, we'll take the image name and change its extension to a .wmv extension. Now this is really low class and low tech, but it does the job. In this case, we know we have JPG files and corresponding WMV files. You might want to change the application so it doesn't have that restriction, but for this simple demo, that's how it works. Now, if the movie file exists, at least I checked for that, if the movie file exists, we'll call the play movie method of our media element, our movie player control, to play the movie name that you've specified. Well, with luck, we've done everything we need to do. So let's save this, press F5, and there's our application. Let's select the folder. There's our folder browser dialog. Choose our movies folder. And now when I click OK, this code takes the selected path, sets the folder name property of the thumbnail list instance in our main Windows code behind class, which is bound to the item source property of the list box, so the selected file should just display in that list. Let's see. And it worked. So we got the JPG files here, and when I select one, the selection changed event handler should retrieve the corresponding WMV file and play it in the media player control, and it does. So now I should be able to pause, play, go back, and so on. So this clearly is doing what it's supposed to do. As a matter of fact, the application really is done. We have managed to select files, bind the list of files to our list box, and play the corresponding WMV file in the media element control that's inside our user control. But there's one more thing we want to do. We want to display these not as strings of file names, but instead as the actual images themselves. We need to convert from a string to an image. Our application is almost complete. It allows you to select a movie and plays it. It should display the video thumbnail in the list box control as opposed to the name of the file as a string. We need some way to convert the file name into the corresponding image, and we want to do it without writing much code. We need some way also to format the image so it lays out correctly in the list box. The answer requires two steps. We need to start by creating a type converter. WPF makes it simple to convert data during the binding process. You can shove your own code in, and they'll call your code as it performs the binding for each element. Our example uses a type converter that converts from a string to the corresponding bitmap frame object, which is what we want to display within that list box. What we need to do is create a class that implements the system.windows.data.iValueConverter interface, and WPF does the rest. We have to write a little tiny bit of code, and then WPF handles calling your method that does the conversion as it displays each file name. The iValueConverter interface has two methods: convert, which converts a value from one type to another as WPF retrieves the value from the data source and binds it, and the convertBack method, which converts the value back to its original type after you've, I guess, modified the value. Well, in this case, we're only doing one-way binding. You can't modify the image from within the application so that it needs to modify the string and the written. Well, that can't happen. So we won't implement the convertBack method. It has no meaning in this application. The WPF designer will call your type converter at design time, and this is a surprise. Normally you would expect it only to call your type converter at runtime, not at design time. I'm telling you this because I spent like half a day wondering why I couldn't get this code to compile. It worked in beta versions of the product, but didn't work in the release version because they changed the behavior for the release version. You must add a check to your code to verify that the input value isn't a null reference before using it. I mean, it makes sense anyway, but I figured if we're doing the conversion, it can't be a null reference, but I had to check. At design time, it will be a null reference, and so you must check for that. Otherwise, you won't be able to show the layout pane for your XAML anymore once you add this iValueConverter code to your project. So you'll see code that checks to verify that the input value isn't a null reference. Let's add our type converter. Back in Visual Studio in design mode, I need to add the class that will be our type converter. So I'll add a class and make it file to bitmap frame converter. And I need this class to implement the iValueConverter interface. And of course, I also want here to resolve that namespace, which is system.windows.data, so that it adds that for us. And in addition, I'm going to add my own namespace reference for the imaging namespace. At this point, we also want to implement this interface. So I'll use the smart tag to implement the interface. There we go, and we have convert and convertBack added to our code for us. By default, both of these methods just throw exceptions. We need to add our own code here. Let me go get the code we'll need. What I need is code for the convert procedure, which is here. I'll go paste that in instead of this exception. So what does the code do? The code creates a bitmap frame named result, and it says if the input value, which is coming to us here, isn't null, we'll attempt to create a new bitmap frame using the value converted to a string as a URI. because that's what the bitmap frame's create method expects to receive. Of course, if for some reason you pass this something that isn't a file path or isn't an image, this is going to fail. So if we fail, we'll just do nothing at all. We won't even bother performing the conversion. In any case, we return the result, which is either a null bitmap frame or the new bitmap frame which we got from the file name that you passed in. In the convert back method, we don't do anything. We should never be calling the convert back method as part of this converter. We're going to need to indicate to the XAML markup that you want to use the type converter when you're displaying those items in the list box control. That is, we need some way of referring to the converter in the markup. It becomes a resource we need to use. We'll add a static resource to our markup that refers to this converter and then add a reference to that static resource where we want to use it. XAML markup allows you to specify resources, that is, objects, things you'll use as part of the markup. These can be classes, images, or other items, and you can specify them at design time. To add a resource, you can add the resources at any level. You can do it at the window element. You can add grid.resources element within the grid. You can add application resources in the application XAML file. The location of the resources element, wherever you add it, governs the scope of those resources, so that if you add them at the grid level, only the grid's XAML markup can use that resource. If you put it in the application XAML file, anything in the application can use the resource. In this case, we'll add it at the window level as a window resources, so we'll add a window.resources element. Within there, we'll add local colon. Remember what that means. That means we're referring to a class in our own assembly's namespace. The local class is named file to bitmap frame converter. We just added that. We need to add a key for it. That is something we'll use to refer to this thing in our code. So we'll use the x:\key attribute and we'll give it a name. Call it whatever you like. I'll call it my converter. The reason we're setting up a resource and not using it directly is because by creating a resource, we could use the same converter in more than one place. It becomes a resource available to anything in this window. We're only using it once. We didn't have to set up a resource, but I wanted to point out how you could create a resource that could be used in multiple places. Here, the local prefix refers to that file to bitmap frame converter class within the current assembly, based on that earlier namespace addition that we added. The key attribute specifies your name for the converter instance, and the x:\, prefix is required because it comes from the namespace imported using the x:, prefix. We'll also create a data template. This is there so we can control the layout of the newly created image in the list box. If you don't have a data template, how would the list box display that image? Somebody's got to generate the XAML markup for that image in the list box. We create a data template that controls the layout of the item, and we supply a data source within the template telling the template where it's going to get its data. The template looks something like this. We'll add a data template with a key, x:\key, that's the name we'll use to refer to this template. So any place we use this template, we'll call it image template. Now you see XAML markup that defines what the template looks like. It has a border, has vertical alignment of center, has horizontal alignment of center, has padding of 4, a margin of 2, a background of white. We have an image within this template. The source for the image is a data-bound value. Look at this carefully. We have markup extension code, which says we're binding the source property of the image to a converter, and the converter gets its value from a static resource named myConverter. That's a lot of syntax to memorize, and it'll take a while to internalize all this. But we've managed to say I want to get my image in this data template so that its source is bound to the results of the converter named myConverter. That's where we hook up that converter to do the work. This data template goes within the resources for the window, just like the previous resource you saw. In this case, the key attribute defines the name for the instance, the border element defines the layout for the border, and acts as a container for the image. It specifies a static resource for the binding for the image source and uses myConverter, which we set up in the previous slide, to supply the image. We have one more thing we need to do. We need to hook up the binding in the list box. Remember, the list box doesn't know anything about this yet. So in the list box, we need to add an item template, which sets up a static resource, which is the image template. On the previous slide, we set up that resource, and now we're saying as an item template for this list box, use that static resource. The list box element ends up looking like this. We'll see this in our XAML markup in a moment. We have to add the item source, which we already added, to do the binding, and the item template so the list box knows what to use as a template for each item in the list box. That's all the list box needs to know. The image template knows where to get the image because it's bound to a converter, and we set up that resource as well. So let's follow this through by looking at the XAML markup and adding all the features to get the images displayed correctly in the list box. In order to add the resource, I need to look at the markup for this window. There we are. Let's get some room here to do it. And up here within the window element, I need to add this code. There's the end of the beginning tag, and here I'll add window.resources. Now I'm typing this one from scratch so you can see the IntelliSense as I type. I'll type local colon, and here's a list of all the classes we've added to our local namespace. The one we care about is file to bitmap frame converter. That is the name of the class, and then we need to give it a key, x colon, and here are all the names provided by the X namespace. It's key that we need, and we'll give it a value of myConverter. Okay. Now, file to bitmap frame converter does exist. They're telling us it doesn't exist. That's an artifact of the designer. We can rebuild this, and it doesn't go away. But we know that class exists, and we know everything is fine. So I'm not going to worry about it at this point. At this point, I need to add my data template. And rather than typing this one, I will go copy and paste it. And the data template includes here a key, so we can refer to it in our markup. We have a border element, all the attributes of that border, then an image element, and the source attribute is not fixed as we've done before with image elements. This one is bound. And so we have XAML extension code here, which indicates we want to bind it to the results of running a converter. And the converter gets its name from the static resource named myConverter. The syntax is kind of weird. It takes a while to get used to it. But whenever you want a replacement made at runtime, or when it's rendered anyway, you need to use a name in curly braces. Static resource refers to the myConverter resource we've put here. There's one last thing we need to do. We need to tell the list box to use the data template. That is, we need to set the item template property. Well, that's easy to do. I'll just go get this. Paste in item template equals, and again, this is a static resource we're using, and the static resource is image template, which is defined right here. And that defines how each item in the list box should be displayed. For each item, we'll take that item using the conversion described by myConverter and convert it from its original value into the new value, which is an image. Well, that's all the code we have to write. I'll press F5 and go. All right, so I'll select a folder again. And look, instead of getting file names, we now see the images in the list box formatted as we asked them to be formatted, inside a border with a margin with the background and so on, centered vertically and horizontally. By supplying that data template, after we've converted the values, we completely control how these items appear within the list box. So should you need to display formatted items in a list box, you can use this same technique, using a data template to format the data. So we've done it. We've built a video browser from scratch, and we've formatted items in a list box, displayed the media down here, and gotten it all to work.